Hello and welcome to Math 8, Unit 3A, Lesson 12. Today's objectives is scholars will use elimination to solve a system of equations. So, this one we're going to call glasses. The last one was interface, this one is glasses. So what if adding the equations doesn't eliminate a variable? Well, it's very easy. We can multiply an equation by -1. And remember, when we multiply by -1, all it does is change the sign. -1 times 5 is -5. -1 times -8 is 8. So, solving a glasses equation. You'll notice here that I have -9y on both of them. That means that if I added these, they wouldn't go away. I'd get -18y. So, I'm going to multiply this bottom equation times -1. So when I do that, I get everything's going to change. So it becomes 4x plus 9x equals 23. Well, that's pretty easy. We're going to bring over the other equation real quick. This is -2x minus 9. Wow. I just realized I made those x's. Hold on, so let's make those y's. Okay, go back here. So this is 9y. Minus 9y equals -25. Notice the top equation didn't change at all. So when I add these now, -25 plus 23 is -2. -9y, positive 9y, that one's going to go away. -2x and 4x is just 2x. Okay, so now I'm just going to divide by 2 on both sides. I get x equals -1. So again, we only have half of our answer here. We have the x value. Now we need to find the y value. So I'm going to use the top equation. I have -2 times -1 minus 9y equals -25. Well, -2 times -1 simply 2 minus 9y equals -25. So now I'm going to subtract 2 from both sides. So I have 2 minus 2 minus 9y equals -25 minus 2. These are going to cancel. I'm left with -9y equals -25 minus 2 is -27. So now I'm going to divide both sides by -9. And I get y equals 3. So my solution for this is -1, because the x is always first no matter what, 3. Okay, let's try another. Again, you'll notice here that my y's both have a positive. So I'm going to need one of them to become negative in order for me to be able to eliminate them. So I'm going to multiply the bottom equation by -1. It doesn't matter. You can do either one, just so you know. So that becomes 3x minus y equals 5. My top equation is still 8x plus y equals -16. Notice the -3x became positive 3x, plus y became minus y, -5 became 5. Okay, so now we're going to add these. 8x plus 3x is 11x. My y's are going to cancel. -16 plus 5 is -11. Divide both sides by 11. I get x equals -1. Again, I'm going to put that back into my equation. I have 8 times -1 plus y equals -16. So that is -8 plus y equals -16. I'm going to add 8 to both sides. -8 plus 8 plus y equals -16 plus 8. So that gives me y equals -8. So my answer again is an ordered pair. X first, -1, then y, -1, 8. Okay. So let's try another one. Here you'll see that I have negative 6x the top and bottom, and I'm going to need to eliminate. So I'm going to need to have one of those turn into a positive 6x. So I'm going to multiply the bottom equation by negative 1. So the bottom equation becomes 6x minus 3y equals 12. Again, all it did was change the signs of each part. So the top is still negative 6x plus 6y equals 6. My x's are going to eliminate. 6y plus negative 3y is 3y. 6 plus 12 is 18. Divide both sides by 3. I get y equals 6. I'm going to start with my top equation here. So I have negative 6x plus 6 times 6y equals 6. Well, 6 times 6 is 36, so I'm going to get negative 6x plus 36 equals 6. I'm going to subtract 36 from both sides, so I have negative 6x plus 36 minus 36 equals 6 minus 36. Here they're going to cancel. I left with negative 6x equals 6 minus 36 is negative 30. Divide both sides by negative 6. And I get x equals 5 because a negative divided by a negative is a positive. My answer, again, x is still first, even though we found it second, is going to be 5, comma, 6. Okay, let's try a word problem. Okay, so the school that Stefan goes to is selling tickets to a choral performance. On the first day of ticket sales, the school sold 3 senior citizen tickets and 1 child ticket for a total of $38. The school took in $52 on the second day by selling 3 senior citizen tickets and 2 child tickets. Okay. So, now we need to find the price of a senior citizen ticket. I'm going to call that one S. And the price of a child ticket. Child ticket, I'm going to say is C. So, let's write an equation for the first sentence I wrote in yellow. On the first day of tickets, I sold 3 senior citizen tickets. So, I have 3 senior citizen tickets and 1 child ticket. So, 1C for a total of $38. The second day, I'll write this one in green, they took in $52. So 52 is what they took in. They sold 3 senior citizen tickets and 2 child tickets. Okay, so what do we notice here? We notice that we have 3S on both of them. But I need one of them to be negative. So I'm going to make this bottom one, I'm going to multiply it by negative 1. So that will become negative 3S minus 2C equals negative 52. Okay, you're going to bring over the other equation, which was 3S plus 1C equals 38. Now I'm going to add. This one's going to go away, my senior citizen. So I have 1C minus 2C gives me negative C equals 38 minus 52 gives me negative 14. Divide both of those by negative 1. I get that child's ticket is $14. So now I still need to go back into one of the equations and find out how much a senior citizen ticket is. So I have 3S plus 1C is going to be 14 equals 38. Subtract 14 from both sides. 3S equals, subtract 14 gives me 24. Divide both sides by 3. I get S equals 8. So again, the last thing we have to remember is we always write answers to word problems as words. A senior citizen ticket, S, costs $8. $8. And a child ticket costs $14. Okay, so go ahead and work on these, and I will see you in class.